Good afternoon. I'm Hugh Dyer, an Associate Director in RSK's Geoscience business. Welcome to the October edition of our 2024 series of Down to Earth webinars. These sessions cover a broad range of subjects through the year and are available afterwards on our YouTube channel alongside previous talks. Our talk today will focus on the design of geotechnical ground investigations and as part of our geotechnical series of talks through this year. Our other geotechnical topics can be rewatched on our YouTube channel. But first, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted through the webinar. During the presentation, you can post questions online and there'll be a Q&A session at the end of the presentation. We'll answer as many questions as possible, but those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you'll receive a link to a short survey. If you can take a few minutes to provide feedback, please, so we can improve on further webinars, that'd be brilliant. Now, please let me welcome our speaker today. Rosie is a chartered geoenvironmental engineer with over 10 years experience in site investigation and geoenvironmental assessment of sites. Rosie leads one of our geo teams within the Hamel office and has worked both across the UK and also within South Africa. I'll hand over to Rosie now to give us an insight into the considerations and challenges of designing a robust geotechnical investigation. Thank you, Rosie.
Thank you, Hugh. I'm just going to turn my camera off now. There we go, so that everybody can see the slides. So, a geotechnical site investigation is undertaken to understand the ground conditions beneath the site, including the strength, the quality, the groundwater profile, and any material properties. Today's webinar is going to cover how to design the investigation. It is worth noting here that whilst the title includes geotechnical, I don't believe that a site investigation should be solely focused on one discipline. Careful planning can ensure that data is collected for a variety of purposes, and this saves money and time on a project. This webinar is broken down into 4 sections, so we're going to be looking at planning, health and safety, different investigation techniques, and then finally sampling and monitoring. Step 1 is always planning, and it's probably the most crucial step in the whole process. But to start this planning, we need to ask ourselves a few questions. What is the purpose of the investigation? What is the historic use of the site? What is the predicted geology at the site? And what are the site constraints? Now we're going to go through each of those in a bit more detail. What's the purpose of your investigation? As part of this, you need to understand what you have been contracted to do. Do you and the client have the same objective? Has this been understood and confirmed in writing? What is the purpose of your proposed development, and what geotechnical category is it in? There are 3 main geotechnical categories defined in Eurocode 7. Category 1 is small, relatively simple structures for when it's possible that the fundamental requirements can be satisfied on the basis of experience, qualitative and geotechnical investigations with a negligible risk. Category 2, these are our conventional types of structure and foundation with no exceptional risk or difficult ground conditions or loading conditions. Category 2 is probably where you're going to be for most of your sites. This would be your housing or high-rise residential. Category 3 are structures or part of structures which fall outside of the limits of categories 1 and 2. Examples of this are very large or unusual structures, or structures involving abnormal risks or unusually or exceptionally difficult ground conditions, or perhaps unusual loading conditions. Structures in highly seismic areas, or structures in areas of probable site instability or persistent ground movements are also going to be put into this category. What you need to find out as part of this is start thinking about what field and laboratory tests you're going to need. and this will lead into your sample requirements. What is the history of the site? Important things you need to think about might include, were there any quarries or ponds or backfilled material? Is there any old buildings on the site or footings, or perhaps there's been some footings demolished that are still underneath? Any basements or marshland? Is there any current or historic cuttings or embankments on the site or adjacent to the site, as things just off the sides to your site could affect you too? Are there any steep changes in topography or slopes, again, on-site and off-site? What is the predicted geology of the site? Understanding the geology is very crucial to your ground model. By this stage, a desk-based assessment should have been completed either by you or your company, or it could have been provided to you by the client. The geology and geomorphology of the site will help you to understand any potential engineering problems, potential methods of sampling and testing, and it will also identify any environmental issues affecting the site. As part of this, you should also consider groundwater, as this may affect the depth of the investigation required. All of the three things we just covered link together for you to form a conceptual site model. Even if you've been provided with a previous phase 1, I would highly recommend creating your own when you're designing the investigation. This could be just on a scrap of paper or in your mind, but it's really important to understand your site. Using your model, you can start to answer more key questions. And yes, planning is all about questions. What to sample? Do you need samples of soil? Do you need samples of groundwater, gas, vapors, or even potentially free product or NAPL? What locations do you want to sample? Is there a targeted approach? For example, you're targeting specific buried obstructions that you want to find, or is it non-targeted? You don't have much information about the previous history, so you're just going to do a grid across the site. What depths are you going to investigate and sample? What monitoring and sampling do you want to undertake? What techniques are suitable to obtain those samples? Are you going to be installing boreholes for monitoring? What in situ testing do you want to undertake? And finally, what environmental and geotechnical testing do you want to schedule? Are there any limits on the detection that you require? Do you need specific types of sample? What are the health and safety risks? And this includes our third parties. What are the environmental and nuisance risks creating contaminant pathways, noise, vibration, or odor? All of these things can be built into your conceptual model, and the conceptual model will really help you to picture and identify where all of these constraints are. So what are the site constraints? This slide looks a little bit crazy, but that is deliberate. I wanted to highlight that there is a lot of things to consider, and the best thing to do is to create a list and work your way through. Site investigations can go wrong if these constraints are not considered properly. If you haven't already visited the site as part of a previous phase of work, it's really important to include a site walkover in your planning phase. It's also important to request data from the client. For example, do they have any service plans? Is there any as-built drawings? Is there any previous reports that you can have a look at? When visiting the site, these are the sorts of things that you should consider and look out for. What are the access and working areas? This is going to help you decide which type of rig is suitable for the site logistically. Surface conditions. When looking at access, you should always consider the ground and surface conditions. For example, like the heavy rain we've had recently, is your ground liable to flooding, or is it going to have rutting or make it difficult or impossible to access? Topography. I mentioned this earlier. Are there any steep slopes that are going to cause difficulty getting your machinery into the right place? Are there any existing structures, including underground basements and foundations, that perhaps you can't get to, or you need to have a look at their current makeup? Are there any underground services or overhead lines that you need to be aware of so that you don't affect or hit these services? What are the predicted weather conditions for when you're going to be there? Is there any public access? So is there any footpaths crossing your site, or any public access that you need to add additional barriers for? Do you need to consider noise? Is there people nearby, or a school? Do you need to consider dust or silt runoff? Do you have a water supply? This is a big thing that often gets forgotten, but most drilling techniques will need a water supply to be able to function. So if there isn't one on site, have a look around and walk around. Is there any hydrants that you can get permission for? Traffic management. Is there any roads crossing your site that you need to consider management for? Or perhaps the entrance to your site is on a really busy road that might be 50 to 60 miles per hour and you need some traffic management to go in and out. Do you need any security on your site? Have you got any particularly expensive equipment that you need to protect, or you're leaving for a long period of time? Or perhaps it's in a, for want of a better word, dodgy area that you need to protect. Do you need any permits, or is there any parking restrictions? So it might be that you need permits to park on the street if you can't access your site. It might be that your site entrance is very constrained on a single track road, and actually you want to put some parking restrictions in so you can add the turning circle of a larger vehicle to get into the site. Do you need any welfare, or is this available on site? Are there any protected areas that we're not going to be able to get to, or we need to investigate first? So perhaps tree or root protection, any ecological species like newts or slow worms. And then finally, are there any invasive plants or potential contamination that's going to affect your investigation and what you can get to? Existing standards may aid your design. There's quite a number of them, and I've put them on the slide here. I'm going to make sure I pause a second so that you can take a screenshot or photograph for future reference. We're not going to go into these in any detail because we haven't got enough time, but I just wanted to highlight them for you. Next, we're going to have a look at the health and safety considerations. The management of health and safety during site investigations can be difficult, but it is a legislative requirement. It requires a fine balance between the effectiveness and the efficiency of all the systems in place. In simple terms, the paperwork is required, but equally the job needs to get done. Poor management leads to a stressed engineer, injury, and potentially loss of life. The best way to ensure health and safety requirements are met is to develop a good safety culture within your team. The next few slides are going to have a look at a brief overview of health and safety for site investigation and the sorts of things that you need to consider. Health and safety, whilst complicated, needs to be made simple, otherwise it can be easily pushed to one side or used as an excuse. When considering a ground investigation, we need to focus on three things: prepare, undertake, and review. Good preparation will make the site investigation safer for all involved, not to mention much less stressful. You need to make sure you've got the project details. Have a look at the driving distance. Do you need to consider worker fatigue or if they need a stopover? Is there access for vehicles and plants? We already mentioned welfare. What are the known hazards on site? Are there any client-specific safety requirements? And what's the BDA classification? And are there any restrictions under CDM? That was a lot of acronyms there. So CDM stands for the Construction Design and Management Regulations 2015. I'm not going to be able to cover the ins and outs of this talk, but it was first introduced in 1994, revised in 2007, and recently updated in 2015. Virtually everyone in a construction project will have legal duties under CDM. There's more details on the health and safety website, and there is a very handy AGS guide for CDM in the geotechnical industry. This is just a 2-page document and really worth reading. The BDA, the British Drilling Association, is the UK's trade association for the ground drilling industry. In 1992, they produced a guidance document for safe intrusive activities on contaminated or potentially contaminated land. And this introduced a site classification system: green, yellow, and red. Green being your simple sites. So I say simple, simple is probably the wrong word. Green being your less risky sites. So perhaps it's a field or a farmer's field and you're not expecting anything to be there or anything contaminated. Yellow would be that there's some contaminated things there, but they can be easily controlled through risk or PPE. And then red is your highly contaminated sites. So perhaps they've got asbestos or large amounts of contamination that you need to be aware of, and you need special mitigation measures in place. Again, not going to go in that to a lot of detail, but there is guidance on that on the BDA website, and also there is another AGS guide to talk you through that. Do you have permission to start the work? This could be from the client, but you also need to consider landowners, local authorities, highways, planners, national bodies, and the Environment Agency. Lots and lots of people, but making sure you have permission. Also, more recently, I've been caught out with this, having permission for service assets. So, for example, from gas asset owners like Cadent or National Grid, sometimes you need permission to work near their assets, so it's worth considering that too. You may also need internal permission within your company, perhaps from a director or a team leader or line manager. Project personnel, who's going to manage your works on site? Do you need additional help for the amount of work you're proposing, i.e. a technician or a second engineer? Are the people you're choosing trained and competent to do so? That leads nicely on to training and qualifications. Some people check this on arrival to site. However, I would always recommend obtaining training records before you go to site. This way you can make sure that the team and any subcontractors you're using are fully trained to do the task before you arrive. The last thing you want is someone turning up without the appropriate training and paperwork, and then you have delays. And trust me, this does not go down well with the client. Things you might need to consider is CSCS cards. If they're using machinery, there might be some specific certificates that they would need. There might even be certificates for the machinery itself, for example, lifting certificates or power checks. More about this can be found in the LOLA and PURE regulations. Are there any site locations and restrictions? So where is the site? Do you need to consider booking hotels? Can you access all the places? Is there any soft ground? All things we mentioned earlier that you can get from your site walkover. If you have got a site engineer and you've identified them before that walkover, it can be really helpful to take them with you so at least they can have a look at the site before they go. Safety documentation, won't go into too much detail, but you need to make sure you've got the two main things, risk assessments and method statements, outlining what tasks need to be done and the risks and mitigation measures associated to do them. Depending on what you need to do, you might also need to consider permits to dig, hot works, working at height, or cost assessments, but it's all very specific to your site. Decontamination and welfare. Generally, decontamination facilities are only required on a red site, so like we mentioned earlier, might contain substances like asbestos or Japanese knotweed. Welfare, on the other hand, is a requirement under the Health and Safety at Work Act. So we need to make sure we're providing this for all of our employees and subcontractors on the site. They need access to toilets and clean water. Communication. Once you've put all of this safety information together, it's really important that you share it with the team that's going to work there. If you can, give it to them up front. This will give them a chance to read through any documentations before they attend the site and make sure that they have the required qualifications, equipment, and PPE. Finally, do you need to use any third-party contractors, and have you checked their capabilities and qualifications? Undertake. Any site can present safety hazards for even the most seasoned of workers. That's why I chose this slide. Just for a bit of fun, can you spot any hazards on this site and any risks that you might want to mitigate? For someone unfamiliar with the site, the risks are multiplied, and simply showing them the ropes isn't always enough to avoid an accident. In addition, you may have regular workers with the potential to suffer from complacency. Before any work starts, you should set out the rules, have facilities in place, and more importantly, establish how health and safety is going to be managed on your particular site. This is usually done via a site induction. Site inductions are really important no matter how big or small your site, and it's important that everyone is on the same page and understands all the tasks to be completed along with the safety implications. If you have prepared all the information beforehand, the site induction is going to be really easy to complete, but you should also consider providing training to those delivering the induction so that you can ensure that they're competent and confident to give that information. Let's be honest, no job goes exactly as we plan it, but we still need to make sure we learn from our previous mistakes and the mistakes of our colleagues. At the end of every job, it's a good idea to take 5 to 10 minutes to think about what went well, what went wrong, any new innovations that you and your team came up with to fix things, Then make a note of these thoughts for future reference, and anything you think could be shared with other businesses or departments. Stick it in an email and share it around. Your sharing could be one less incident. Moving on now, we're going to have a look at the different types of drilling rig and their capabilities. Investigations can be split into 3 stages: a non-intrusive, intrusive, and in post-investigation. We're going to have a look at each of these 3 in turn. There are a few non-intrusive methods that we can consider when planning our investigations, including geophysical methods and photogrammetry. The majority of the work is generally in the upper 20 meters of the ground, but typically for our sites and our ground conditions, it's going to be in the top 2 to 5 meters that these investigation techniques are going to help you. Geophysics includes techniques like seismic refraction, electrical resistivity, and ground penetrating radar to gather subsurface data without breaking the ground. The main applications of geophysics include identifying buried obstructions. For example, if you're expecting buried tanks, culverts, tunnels, or even buried concrete. I've seen this used before to identify buried concrete and their thicknesses on site without having to drill lots and lots of holes. Voids, whether these are man-made or natural, geophysics can help identify voids in the ground, for example, mine shafts, caves, solution features. Ground conditions, such as contaminated ground, landfilled areas, or even wet spots or wet beds, these can also be identified with geophysical techniques, and it will produce a nice handy map that you can target your intrusive investigation with. Geological assessments can be done, so perhaps the variations in an embankment fill, the depth to bedrock, any faults or anything that might affect earthwork stability. Finally, you can also do structure investigation, so looking at floors and walls and soffits, but let's focus on the ground for now. It's always worth considering geophysics. As it's a non-intrusive technique, you might find that you'll be able to get a lot of data without having to churn up your site, which can anger farmers if you're working in fields, or it could obstruct works if you're working on live sites, for example, car parks or railways. Right, intrusive techniques. There are many intrusive techniques to consider, and they all have their own limitations. You could do trial pits and trenches, so like in the top right of the slide. These are undertaken with hand tools or could be using a machine excavator to visually inspect the soil layers and collect samples. They're very useful for shallow investigations. It's worth bearing in mind that generally you can only get disturbed samples from this type of technique unless you're going to start including shoring and getting man entry permits. Then we've got boreholes. There's different types of rig for different types of boreholes. I've shown 3 different types on this slide. So in the top middle is a dynamic sampling rig, bottom left is a rotary rig, and in the center bottom is a cable percussion rig. These drill smaller diameter holes to extract soil and rock samples. The common methods that I've already mentioned include dynamic sample, cable auger boring, and rotary drilling, but you also get percussion drilling and sonic drilling. Generally, our dynamic sample, so the one in the top middle, is used for investigations up to 5 to 7 meters. But then our cable and our rotary drilling can be used for deeper investigations going up to 100 meters. All of these techniques have different forms of in situ testing. This is conducted directly onto the soil to measure the soil properties. So, for example, standard penetration testing measures the soil resistance to penetration. Cone penetration uses a cone-shaped device to measure the soil resistance and gather data on soil stratigraphy. There's lots and lots of different types of cones, and the van in the top left of the slide here is just an example of a CPT rig. These are usually quite big rigs, usually a lorry type size, but you can get smaller tracked ones. Pressure meter tests, so this measures the soil deformation under pressure. Vein shear tests, so this determines the shear strength of any cohesive soils. And then in situ CBR testing. This determines the soil's capacity to support loads or withstand deformation. This next slide, again, has quite a bit of information, but I've tried to provide you a comparison of some of the more common techniques that we use. As you can see, there's quite a variety of depth ranges, working areas, and sample recovery. This is why it's really important to consider your ground model and understand what depth do you need to get to and what samples you need to recover, as this is going to really affect which technique you choose. In addition to this, you've got your site constraints that we spoke about earlier. Can you get those specific rigs onto site, and is there enough space for you to set up safely? So just to go through a few of these for an example. The trial pits we mentioned earlier, I said that you could get a disturbed sample. Generally, there's no built-in equipment for in situ testing, but you can use hand equipment for in situ testing in these areas. The dynamic sampling, up to about 10 meters, depending on your ground conditions. If you've got very dense gravels, you're probably not going to go very far at all with this rig. It has got a smaller working area, and generally it can get through doorways of about a metre in width. You can take off the sides and sometimes get it down to 900 mil. The cable percussive, rotary and sonic ones are generally much bigger rigs, but you can get your undisturbed and semi-disturbed samples from those types of investigation. What I haven't mentioned on here is the cable percussive rig actually has a different type of rig as well. There is something known as a cut down cable percussive rig. So the cable percussive rig in itself is quite tall, nearly 3 meters tall, but you can get a cut down version that people can manhandle into basements. So that's also worth considering. Post-investigation, samples are sent to the laboratory for testing. Typically, soil classification tests are used to determine grain size, Atterberg limits, soil type, and strength to measure properties like shear strength, compressibility, and consolidation. Another post-investigation technique is monitoring, which moves us nicely onto the final section of our webinar, sampling and monitoring. Taking samples and scheduling testing is really important to help us validate known facts and remove data gaps and uncertainty. Monitoring is a post-investigation technique used to understand groundwater, ground gas, and vapor, as well as potentially ground movements. Eurocode 7, Part 2, ground investigation and testing is the main thing we need to consider here. There are 3 main categories of sample collection defined in Eurocode, and they're crucial for determining the suitability of samples for various laboratory tests. Category A are your highest quality samples with minimal disturbance. Generally, we term these undisturbed samples. These are mostly collected using rotary techniques or using a U100 tube. You can see that in the top left photo. Those are UT100 tubes, so thin wall undisturbed sampling tubes. Category B are moderate quality with some disturbance, so these would be your split spoon samples or samples taken from a window sample tube or auger boring. So they still have some small undisturbed parts in the center, but they're disturbed on the outside. Finally, category C is our lowest quality, and they are significantly disturbed. Generally, these are disturbed samples and would be our bulk bags or tubs. So I've put a photo there in the bottom left. During the site investigation, it's really important to collect a variety of samples to enable the soils to be classified. Generally, the testing is constrained by budgets. However, more information you can obtain, the easier it will be to refine your ground model and review and remove those data gaps from the conceptual site model. Sample selection should be based on the questions that we've identified right at the beginning in the planning stage. What's the purpose of the investigation? What's the site history, geology? And in addition to this, you should consider the category of any proposed structures that we mentioned earlier. It is important to consider the sample category before choosing the investigation techniques. As we identified on the earlier slide, the different techniques can collect different levels of sample. The UK National Annex for Eurocode does include a checklist for the different soil classifications tests. Whilst it's not exhaustive, there is a good starting point of what tests can be undertaken. As you can see from this snapshot of Eurocode, depending on the sample and quality class, the sample category and quality class, it will depend on what types of testing can be undertaken. During the investigation, observation wells are often installed to monitor groundwater levels and flow. in addition to gas and vapour if required. Piezometers can be installed to measure the groundwater pressure at specific depths, and inclinometers can be installed to measure ground movements. Settlement plates can also be used to measure vertical ground movement. The requirement of each of these measures will be very dependent on your ground and your conceptual site model. So in summary, it was a brief run through today, but I'm hoping you've got the following takeaways. That it's important to first understand the purpose of your investigation. Look into the desk-based research and create your ground model or conceptual model. Look at the data gaps in your model and consider what sample types you might need. Think about the potential constraints, safety, site access, invasive plants, contamination. Consider all the different techniques available to you, intrusive and non-intrusive, and choose the right ones to collect the right category samples and in situ data for your particular design. When sampling, it's crucial to obtain the right category and quality sample. Finally, should you consider any post-investigation information, or do you need to undertake any monitoring? Thank you for listening. I'm going to turn my camera back on now for any questions.
Firstly, thank you, Rosie, for that very, very good, informative run through how we plan our site investigation. And I particularly like the inclusions of the Lego models. We've had a few questions come in, and I think we might have a few more come in as we go through this. First question I've got: what are the options for investigation on sites with very soft ground conditions? You mentioned about looking at the ground conditions before we go to site. I suppose where we do have very soft ground conditions, what can we do to get across there to do investigation?
Well, first, it depends on how soft they are. It might be that you can use some road plates or some big track mats to be able to get your vehicles onto site. With that being the case, you probably want to use something like a CPT rig, as this is going to give you the most data from the cone. Because once you start using the percussive rigs, they're going to sink very quickly, and the data that you get is going to be a little bit meaningless, whereas the cone penetration device, depending on what types of cone you pick on the end, can give you a lot of information from very soft soil. We've actually done that on a site recently where we went and we did a cable percussive hole. The ground was so soft that the SPTs were up to about 2 to 15 meters, and we've recently gone back with a CPT rig and managed to get some more useful information to be able to give the client a better indication of the ground conditions and a design.
Right, okay. So there are particular rigs that are better suited to the soft ground.
Yeah.
Excellent. Another question here: are multiple phases of investigation needed? I think that probably depends on the site.
It depends very much on the site, yeah, and it depends on your client and what they want to pay for. Generally, the reason we get multiple phases of investigation is, for example, if your client's looking to buy a site, they might want just a quick overview of what's there rather than something more detailed to decide whether they're going to buy it or not. And then your second round of investigation would be a bit more detailed and go into a bit more depth of the design. So it would really depend on what phase the client's at in terms of what they want to do with the investigation.
Okay, we've had a few people ask, how do we determine the number and type of boreholes or investigation locations to undertake, particularly the depth of investigation?
So the number of locations, I can't remember exactly which guidance document it is in, but there is a guidance document from that list that I put together that will give you an example of what grids you should use for your investigation. But generally, it's like a sample every a location every maybe 50 meters on a grid. But it does depend on what you're looking for and the size of your site. Obviously, you don't want to do it every 50 meters if your site's something like 80 hectares. It's going to be a ridiculous amount of holes. But there is some guidance out there to tell you about that. For the depth, it would really depend on, firstly, what they're proposing to build. So if they're proposing to build some low-rise housing, you're probably not going to need to go very deep. But if they're proposing to build a 20-meter apartment block, a 20-story apartment block, you'll probably want to consider a deeper investigation, because you're going to start looking at those pile designs rather than shallow foundations. It also depends on your geology. If you're looking at a site where it's tidal flats, you know instantly that that's going to be very soft material. So you're going to want to go deeper, because they're going to need deeper foundations to be able to support the loads. Whereas if you're in an area where you're straight onto limestone at a meter down, you're probably going to be able to do a shallow investigation. So it's very dependent on what they want to build and the geology that you've got on your site.
So really getting to know the site and having that conceptual site model at an early
Yes.
stage. Yeah, fantastic. Can geotechnical and contamination testing be undertaken in the same boreholes?
Yes. There's a simple answer to that question. You need to take different types of samples. So your geotechnical testing, you might need to get undisturbed samples or disturbed samples, whereas your contamination testing, you might need little jars or preservatives, depending on what you want to test for. But yes, they can both be taken from the same holes.
Right, got a couple more. How long does, this is a tricky question, sorry. How long does a cave percussion borehole take compared with the rotary borehole?
Oof, that depends again on the geology. I would say if you've got, and it also depends on the driller. The cable rigs are very dependent on the driller. If you've got a very experienced driller, they can be very quick. If you've got a little bit more inexperienced driller, because it's very manual and dependent on the user, that type of rig, that could affect it. Whereas the rotary rig is a machine. Whilst the user needs training, it's not as dependent on the feel of the rig to be able to get the depths. But generally, in my experience, the rotary rigs generally take longer, around probably 7 to 10 meters a day, depending on your geology. Whereas the cable rig, if they get good geology, and by that I mean something simple for them to drill, for example, London clay, they could probably drill 15 to 20 meters in a day with a very experienced driller. So it's a very tricky question, but it's very dependent on the geology and the driller that you've got operating.
Yeah, yeah. And also they do different things. So using a rotary rig to go through sands and gravels and clay, as opposed to using cave cushions, it's a different technique, really, isn't it?
Yeah.
But yeah. Sorry, very, very tricky question. What's the difference between a standpipe and a piezometer? I think this one comes up quite a bit.
Well, it depends. It depends what type of piezometer. So you can get a standpipe piezometer. A standpipe piezometer has a little, probably 300mm tip on the end, and that 300mm tip is essentially the same as a piece of slotted pipe, but it does have a bit of element in there, and that will be, you were targeting that 300mm depth with that standpipe piezometer. But then you also get a vibrating wire piezometer, and you also get other different types, whereas the standpipe is just a pipe in the ground. There's no other way to put that in. You can vary the depths of the pipe, so you can have different zones of how much slotted screen you want to put in. But that's the main difference, is the vibrating wire or the piezometer is generally measuring the groundwater pressure, whereas the standpipe is going to just tell you the groundwater level, and or if there's any contamination like El-Napple floating on the top, for example. The standpipe is going to tell you that. So, yeah.
Okay. Got an interesting one here.
Cool.
How do we weigh up doing the carbon emissions in doing the ground investigation as opposed to the additional carbon emissions by specifying, it says extra pile length, but say more robust foundations? So in terms of doing further investigation, maybe to reduce the foundation required against actually we'll just put more concrete in the ground.
I guess you would have to do that on a calculator of some description. There's a variety of carbon calculators out there. You would have to, depending on the depth of your investigation, so for example, say you're wanting to put in a 30-meter pile, your borehole is going to have to go to 35 meters. And that's not an insignificant amount of work. You probably have to have the rig running and on site, I would say, depending on the geology, for about a week to get that borehole in place. But then again, if you do that borehole, you might find, oh, actually, I can reduce the pile lengths to 20 meters or 15 meters because you found good ground conditions. And that conversely could save a lot of money for the client. So I think it's not an easy question to answer, but you could put it into a number of calculators to be able to identify, okay, how much carbon is it going to cost me to do that week on site? And how much carbon is it going to cost me if I put in a 35 hole, a 25 hole, or a 15 hole? And then from those calculations, you can decide, okay, it's worth doing that investigation, or actually the carbon saving isn't that different between a 35 and a 25 meter hole. So we may as well do the deeper ones without that investigation. But it would have to be a calculation.
I think, yeah, experience has shown that almost carbon follows cost to an extent, and that yeah, by doing more investigation, you generally will save on carbon and cost in the long run, as opposed to reducing your site investigation and ultimately cost more in foundation costs and carbon costs. So yeah, yes, interesting question. Someone says, have you got any comment in site investigations within coal authority areas? So coal authority, coal mining areas, where there's potentially shallow mine working. So I don't know whether you want to take that one or whether you want me to answer that.
Do you know about coal, Hugh? Because I was about to say that I don't know anything about coal authority. And I'll put my hands up and say I don't know.
Yes, yeah. No, that's fine. Being down in Hemel, I don't suppose you come across much.
No.
But being up in the Midlands, surrounded by mine workings and so on. Yeah, so investigation in coal mining areas. Yes, having again, going back to having a really good understanding of your conceptual site model. There's usually very good coal mining records, particularly around the medium to deeper mine workings, and also a good, we have a very good understanding where there's likely to be shallow coal. So having a good understanding of the mining areas, coming to someone who's got a good background in mining, helps you to design then your site investigation to target those potential seams at shallow ground, but also to understand where actually you probably don't need to go 60 or 100 meters depth, because if you've got that rock cover above the potential mine workings, and to have a good understanding of what you're looking for and how to target that. I think, again, yes, going back to a really good, robust depth study, conceptual site model, understanding what you're looking for, and also, as you said, Rosie, understanding what you're investigating for. you know, if it's just to understand for a large site whether it is contaminated or not, or at an early stage, it will then inform what your site investigation will be. So yes, thank you for that question. Someone else mentioned about the risk of unexploded ordnance on site and how would we address this? I don't know if you want to take that one, Rosie.
So generally we'll do an initial screen. There's various websites, but we use the Zetica one, and it just gives you an initial indication of whether your site is in a low, moderate or high risk area. And then also you should have, as we mentioned earlier, you should have already had some historic maps or a phase 1 assessment. You can have a look at that and see, okay, is there any bomb damage historically on my site, as well as looking at the area. And then if you are in an area that's moderate or high risk, I would highly recommend going and getting a desk-based assessment from a professional, because they would then instruct you as to whether you need to have mitigation measures in place while you're on site, or whether your site actually could be risked away depending on what happened there. But it would be getting an expert involved to help you with that.
And shameless plug, sorry, but yes, we do have RSK ordnance now, who we generally go to on an informal basis, and then obviously on a formal basis to get those assessments done. Right, I think we will end the questions there. We've had some really interesting discussion. We have had quite a few questions come in, and those that we haven't got round to during the webinar, Rosie will have a look through those and try to answer those afterwards. So our next Down to Earth talk will be on Tuesday the 12th of November, and we'll be focusing then on how the geosciences community can contribute to supporting sustainability. So thank you ever so much, everyone. Please remember to complete the feedback following the presentation, and have a lovely rest of your day, and see you in November.